So when you look at this topic here, it says mobile phones, secondary OS, SIM card, and SMS. We're going to see three entities which are connected here. One is the mobile phone secondary OS. What is secondary OS? Like, for example, if I ask one of you, or even myself, I would say, what phone do I have? I would say simply, oh, it's a Windows phone, or Android phone, iPhone. But what is this secondary OS? Most of us, we don't know sometimes, but the SIM card which we inserted inside the phone, that's a secondary OS. Right, that's one. Then the SMS one. Of course, we all know, right? SMS is like a text message, like, dude, where's my car? Right, we send it. So, but that's one side of SMS. But there's another side of SMS called binary SMS, which we're going to see in that angle. And the third one is, using these two, we're going to see a business case or business application called M2M communication. It's called machine-to-machine, right? I'm going to just scratch that a little bit now. In the earlier talk, I was attending this designing with sensors. It's like you collect data by connecting with different kind of sensors and do certain things. That sensor is, those things we call it IoT, or Internet of Things. But M2M actually a platform to achieve Internet of Things. So we're going to see how these three are connected. And right. So a little bit of myself. I'm basically a programmer myself. So sometimes my legs might be doing some Elvis dance, so don't worry about that. And feel free to ask any questions in the middle. There's no like wait till the last moment. If you don't understand, dude, I don't understand. Just repeat it again or something like that. Cool. So in my previous work, I worked in something called device provisioning platform. That is something like for example, you have a cell phone a subscription from Telenor, and then suddenly you change to Netcom, and you get a new SIM card and put it in, and within a few seconds you get an SMS, something saying, okay, do you want to install these settings for the new phone? Like, do you want to access the internet settings, or do you want to like send MMS settings, those things? That's the system which does that. So we have a standard called Open Mobile Alliance, which defined this standard, how to implement those. So I was working with that. And the second one is the cool thing. How I'm going to access this secondary OS, which is in my mobile, without knowing the end user. And the mobile phone also doesn't know anything about the way I communicate with it. Totally abstract and totally below the scene. Right. So we're going to see those things, right? And sometimes I refer this specification number here. So people who know, like there's a standard body called 3GPP.org. They maintain these particular standards, how to implement and how to refer this certification, because there aren't any books which explains these things. So it's better to, those things really helpful, because in those 3GP section, there are like 100,000, not 1,000 specifications. So it's much easier to pinpoint, okay, to go that particular location and find the stuff. Right, SIM card. Just found it from a cool site. You see, somebody had posted like iPhone SIM cards, like 3GS, and then every time it goes slower, SIM card size become much smaller and smaller. The first SIM card is like, so, and the last thing it says, no SIM card. Well, first of all, what is this SIM card, right? So I just gave a small explanation, like it's actually a gateway for an end user to actually access the network provider services. Like for example, if you have a Telenor Netcom, something like that, you want to use their network and send MMS, SMS, internet, any services. They need to know, and they need to bill you, right? They need to identify who is accessing my network. So those informations are actually in the SIM card, which you get. Actually, the 76 or 789 doesn't exist anymore. It's just for fun they have done this. But so if we go a little bit further down, a little bit like half technical term. That means SIM means subscriber identification or identity module, right? But we just simply call it SIM. It's much easier to know because that standard came like in 3G before 2G stuff. Okay. And the third thing I given is like, these little technical terms are sometimes a little bit confusing, but it's nice to just show it here. Like GSM stands for Global System for Mobile Communication, which was old stuff, 2G. Then we have this Universal Mobile Telecommunication System, which is 3G. And now the LTE and LTE 4.5 is up. The reason is more speed. You get more bandwidth to access data. And more Internet of Things going to happen through those LTE stuff. There's something cool called proximity sensing. I'll come to that later on. Right. The cool thing is, I always say cool thing, but the SIM card actually has a microprocessor. It's like a small, tiny computer. Even this is a tiny computer, but inside this, there's another tiny computer which works independently. But we can access it, we can control it. That's what you're going to see in this talk, how you're going to tap that thing, right? When it comes to technical terms, there's something called UICC, like Universal Integrated Circuit Chip or Circuit Card. Either way, we just refer them as SIM card or UIC. More technical term is UIC, but we call it SIM. So sometimes in my slides, I might be referring UICC or SIM, okay? Right, a SIM card, which you get it normally, a small thing, like, I don't know, 10 millimeter stuff. So these are the applications or applets in those small SIM cards. For example, I am showing you here, you have one phone book, you have this USIM, SIM, public transport details, payment modules, e-health, ID, M2M. These are like small applets on top of the SIM card. You must be thinking, what is a USIM and SIM? What is a SIM what is this SIM is doing inside the UIC? Like earlier version, there's only one card, and that has only one module called SIM. So that's why we call it SIM card. But now the technology has more advanced. We have more modules, and we call them, like SIM is a module inside the UICC card. It's like part of it. It's not the entire thing, it's part of it. That means that modules give us the rights to access the network operator's services. USIM is like universal SIM, that is for 3G or LTE services onwards to access it. The payment gateways, IDE, like bank ID, which we're using sometimes, like, I don't know, when you switch to use bank ID services, sometimes you get a new SIM card because they have to install certain apps on your SIM card if your SIM card is not supported. But if your SIM card is already supported, they do it over the air. We're going to see how they do those stuff. So if you ripped the SIM card, you can see the processor, a tiny processor inside the SIM card. And the three things, well, currently now the latest one is a nano SIM card, which is iPhone 6 is using it, I guess. Yeah, it's much more smaller. You need a kind of a plate to put it in. And on the right side, there are certain structure. We call it a file system, because since it's a OS, it has a microprocessor, some memories, and some file system which contains details. It has those sensitive details, like, for example, encryption keys, algorithms of how to encrypt the data traffic, voice traffic, because we want to keep our data safer. So the SIM card contains all those information, like the algorithms to encrypt your data traffic. Like, you might be thinking, like, when I talk, can somebody ever stop my talk? It's not possible because they encrypt all this data. So how does a phone knows what to use and what type of keys to use to encryption things? So those information are fetched from this file system. And if you need to do certain things, we had to write it in this file system. But normally, normal phone apps, they don't provide you this facility. So we had to go a different way of doing that. Right, so since I said the SIM card, it has an operating system. But in mobile context, there are two secondary OSs. One is for the baseband and one is SIM card. Baseband is not our topic here at the moment. That is the one which deals with how to communicate with radio networks. We are not going to touch those things here. We are interested more on the SIM card stuff. So as I mentioned here, it provides encryption, storing the sensitive information like NFC or credit card details in the SIM card. And one cool thing is, the new versions have a web server embedded in your SIM card, a tiny web server. That means an authorized person can query your card and get details, like what is the latest settings, do I need to update the key, or those kind of information. So it's like, I can't believe, right? We have a web server embedded in a SIM card. Even a SIM card is much more lighter. It's crazy. So these are some sample SIM card operating systems. There are some providers like Gamalto, GNT, those guys, they have their own native OS. And Java card came to give a common platform. We know that Java is like a platform independent, like platform interoperability to run in any operating system. Even in the smart card world, we have JVM installed. That means you can create one applet which can run in any different smart cards. So we have one common language. But to write it, there's a nice presentation in DEF CON, one of these US presentation. They have did some hacking on this thing called the secret life of SIM cards data. That is, they focus on how to write applets and how to do the things, and how to install those things. But in my talk, we're talking about, we're not going to write applets separately, we're going to use what is already built in and how we're going to access it through SMS. So in that talk, they were talking about how to communicate with the SIM card OS. So they were using a PCC reader. That is, they connected to the PC and they have these Python scripts to talk natively with that SIM card. But our focus is talking it via SMS. We're going to talk with the SIM card with SMS. Okay. This word APDU, I'll come to that later on. Right. If I say SMS, generally it's like a word, like we say, send me an SMS, like when it's lunchtime or things like that. But there are as I said earlier, we have two varieties. Text messages, which we normally use as a general population, we use it. The next is called the binary message, which is in hexa encoded, and you don't read it. It's not for human beings to read it. It's much more machine to level read it. And when you receive a binary SMS in your phone doesn't blink, it doesn't show anything. You cannot even know that SMS came to your phone. Suddenly you might be saying, oh, your phone is out of signal, so you try to restart it. That's the only thing we know. But things happening is behind the scenes, those binary SMS comes into play. There's another thing there are some varieties of SMSs. Replaceable SMS. That is like, I was playing a prank with my work buddies here. I used to send them a message saying, dude, the pizza is ready. And then I send another SMS which overwrites it. And he was saying, dude, I got an SMS, the pizza is ready, but where's it? I said, can you check the phone again? And he checked and said, I don't have the SMS anymore. And he was like shocked, like, how did you do that? I said, it's because it's a feature of the GSM where you can overwrite a sent SMS. Sometimes like bankings, or they use this approach, like tokens, like to log into a security environment, you need like secret key or secret number to receive. So every time you log in, you get a new SMS. Instead of piling this SMS, they overwrite the same SMS again and again. So you'll be having only the latest one in your phone that shows the latest number. Then we have this silent SMS. I'm sure you would have heard about this sometimes back. It was German police, they were using the silent SMS to track people. The idea here is like the binary SMS, there are certain flags. You set those flags, like the PID flags, we call protocol flags. So those flags, what happens is like once you receive it in your phone, it doesn't show any sign at all, but it will report to the cell tower the latest location which you have been last known. So automatically the police can identify, okay, this is a place he knows. But he doesn't know, or the person doesn't know that he has been tracked. That's one called silent SMS. Then the last one called flash SMS. That's quite old stuff. That is like you get SMS, it automatically pops up in your screen, but it doesn't get stored in your inbox. Because I'm using the Senthuran account, and sometimes I get the SMS. So you couldn't find it later on. Like you get a PIN code for like 10 minutes active time, then the SMS is gone. There's no recovering back. So those are things called flash SMS. It's only a matter of changing few flags of doing this stuff. So some business applications which using this SMS behind the scene, like authentication where the bank IDs install their public keys in the phone to authenticate yourself. Then the old style of notification service where you have your weather report or some statements, you get a simple SMS. When I talk to some people, like I'm going to talk about SMS, they all thought about this alert service. I'm going to do alert service, but this is much far beyond that. And this NFC chipset, okay, we have something called near field communication, where you have your NFC card or installed in your phone, where you just have to tap the payment gateway to get transaction. So they were like started with external chips where you paste on top of it or do something like that. But 3G, they come with a new standard called embedding the NFC chipset inside the smart card itself. So even iPhone, which doesn't allow you to have external, but now iPhone 6 is giving you the option, but still they're asking you to go through Apple Pay gateway, things like that. But any phones without external circuits, with this SIM card which has embedded NFC chipset, it's possible to do a transaction. So it's coming. And the last one is M2M. That's what we're going to see a little bit deeper, right? So vehicle management system, and okay, we heard about this. Tesla is quite interesting, right? A lot of people like to show in their mobile phone and say, oh, my car is there. I can even, from here, I can make a signal, I can turn on the heater, things like that. But the cool thing with Tesla is like there's an engine diagnostic system which actually collect your sensors and see if, logs all the details and see if something troubles, it automatically signals to the service center that you need to have a service to repair something is wrong with your engine or the sound. How do they communicate that? If you don't get Wi-Fi in all of the places, sometimes, but when you're roaming or you're traveling a lot. So to connect these things, they're using a SIM card. I can show you a picture. I was doing some search, and this is a motherboard in Tesla, and okay, this is the SIM card. So actually a SIM card is embedded here, and that communicates with the service center. There was an article like saying Tesla has chosen Senthuran to provide M2M service. That is like Tesla will be using netcom services to communicate with their service center. But the number one challenge in M2M is I want to change the provider or subscriber. Like for now, I'm going to say using netcom to do all the communication. Suddenly, the netcom has increased the price, and Telenor comes and say, okay, we'll give you, Telenor X comes and say, okay, we give you a good a deal. Like you have like 100,000 cars connected, I can give you a good deal. So you need to swap. You need to swap the provider. How are we going to do that? I mean, one option is like call them, call all the cars, come to the service center, change the SIM card. That's not going to work because in this scenario, it might work, but there are scenarios where you have embedded your SIM card, like monitoring the oil departments or cargo transactions, where you can't reach those places and change the SIM card. Then comes the technology called over-the-air changing. That is called OTA, over-the-air technology comes into action. There's a feasibility study I just included here, which says how you can handle the security in M2M transactions. So how are they going to do this in OTA, or the over-the-air thing is using the SMS. That's what I was saying. We're going to talk with SIM card with SMS. Right. There's a huge little deeper specification saying how to do this. Like there are, when they designed this, when telecom sector designed this over-the-air section, they want to really keep the monopoly themselves, and they want to make sure it's much secure, and they don't want a hacker or a cracker to hack into these networks, and so they have defined certain protocols, which is like certain keys are embedded in your SIM card, and in this SIM card are actually designed in a way they are much more temper resistant and heat resistance. And if you try to change the voltage, it will automatically lock itself. Or if you try to short circuit with a different adapter to read certain area, it will automatically short circuit. It will lock itself, and that's it. The card is dead. You can't get that information. So only way to access it is by using those keys. Like the keys I have mentioned here is like KIC and KID details. It's called cryptographic key and checksum keys, where they make a digital checksum. Good thing is, even while I was working with this, you don't get this key. Even the operator doesn't get that much keys. They get only a few set from the manufacturer. The SIM card manufacturer gives them only one set of keys. And the operator he will never give you the keys unless you have a good deal with them, or if you're really doing a good agreement with them that they will give you the keys. Because once they lose the keys, that means somebody else can start provisioning or change entire traffic to different gateways. It's like keeping the key to the, you become a god to the SIM card. So those keys are very hard to get, but luckily for me, from a developer, I got those keys to play with it. The keys are like 16 bits, and they use encryption called triple DES, so it's much stronger. Okay, so the concept of changing the subscriber in the SIM card is called remote management, and we call it RFM, SIM RFM, called remote file management. It's like, okay, I can show you. So this is a typical binary message. Quite nice, this is. A lot of numbers there. But, and that's a nice picture. If I decoded those numbers, actually each number gives a different meanings. For example, 06 is like saying, okay, the service center's address length, the number, all these fields gives different options. So when it comes to testing these things, and normally these technology ideas or the concept are not, even the specification doesn't mention that much deeper. It's like a lot of trial and error in order to identify. Even a single byte or bit changes. The phone will simply say error, oops, that's it. And you don't know what's happening because you don't have much control with the phone, because once you send the SMS, the phone is, it starts to behave. So we have to have some tools in order to eavesdrop or have a middle layer to identify how the communication goes up and down. Okay, right. This is a little bit high level, like, okay, I have composed this SMS now. In this example, okay, the last line, you see the TP user data. That's actually a SIM RFM message. That's saying, okay, go to this directory, open this file, change this value to this. That's the command here. So we have to pack this along with all the other information to send them. So normally it's very hard to send this kind of messages to your phone, but it's possible to do some hacking purpose. So this is a very high level telecom architecture where what we're really interested is actually this SMSC, the one over here. This is the one which exposes the telecom sector to the internet. Like if you want to communicate with telecom sector through SMS or through your PC or machine-to-machine communication, they had to go through that gateway. Other than that, there aren't any other possibility to go inside the telecom network. So I just gave the screenshot here. Right. So in the earlier diagram, I mentioned something called iPhone 6. The SIM card goes smaller, 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 and suddenly disappears. The reason is now they're looking into something called embedded SIM card. That is, your SIM card will be embedded in your phone, and you can change it automatically. That means even if you lose your phone, nobody else can. You don't need to worry about it because they can't manually go and change the SIM card because it's embedded inside. Unless if it's a good electrician, do some fancy things. But general user, they can't do it, and it's highly like hard-coded thing. So they need to have these remote SMSs things in order to change them. That's the binary SMS comes into action. There's something called like misuse of binary SMS. We have this SMS-based DOS attack. Like if you know this guy is traveling and you want to like suck all his battery power. Okay, he has like iPhone 6 and you know, okay, like 6 hours he can battery life. You want to make sure he's not going to get this important call. You want to make his battery died within half an hour. What you do is you send this kind of SMS with the wrong keys. So your phone actually going to use more power to decrypt those things, but it's going to fail. And phone doesn't going to report you error. So you keep on sending it, poop, battery dies. And then there are some other things called premium SMS, like you're going to have a service like buying a ringtone or things like that. So you send SMS, it's actually going to invoice in your bill. That's called premium SMS. There are some hackers who done this, like the weak SIM card will give you access to do those things. There was a German researcher has done these things, but that's because the SIM card was using a very weak algorithms to do it. But most of the things are okay. Right, important thing is like, I always think, the reason I was giving talk is like this knowledge is actually not publicly available, not that much. It's very hard, like you need to dig more and more articles, research, more tools to hack these things. So I was thinking, there is a possibility to have a virtual network card. Why can't we have a virtual SIM card? Maybe in the cloud, things. So just I'm thinking open loud. Like if you all have some ideas, we can do something. Because the telecom is actually playing a big monopoly on this SIM card because no matter how big phone you have, ultimately it has to go through the SIM card. They catch us. So if you could something like cloud-based SIM card or virtual SIM card things, it'll be awesome. Yep. That's it. Hope got something, some information about SIM cards, what's actually happening inside. Any questions you can ask? Or you can catch me later on. Yeah? Can the binary SMS be sent from another phone? Yes. Windows Phone doesn't give you rights. It gives you rights only if you belongs to a network operator, like you're part of them. Android is possible. iOS, I don't know. It's very hard to get into. Android, there are some tools where you can actually access the radio interface layer, and you can send SMS. So if you know how to set these codes, you can send it. The only thing is they're going to bill you, because you can send your own phone. Yeah.
I've been talking to you earlier, and you mentioned some apps that can protect your phone.
Yeah. Like there are some, like to catch this silent SMS that you want to know if somebody has sent you a silent SMS. There are some Android apps which works in the low level. It will trigger and say, okay, you received a silent SMS. And it will give you an alert. Or they can say, check, okay, if you're going to access a wrong or a dummy or decoy baseband or radio network, it will automatically identify and give you, shows you, okay, you're trying to access a wrong cell tower. It is like maybe some management is using to track to see who is accessing this radius. So those things are possible. But Android phone gives you the more features. So most developers, they like Android because you can do cool things with that. Okay. Yes? Normally, it's not possible because only trust we have is that key. Because it's like a PKI public key infrastructure style. So telecom knows one part and we have the other part in a phone. So they use both keys to make the messages. So without those keys, it's not possible. Phone will simply reject it. So in that case, that keys are very, very safe and it's quite good encryption techniques. So it's Otherwise, the telecom sector would have been fallen down because it's not. It is much easier to attack. And although there was a German researcher did this, but that key was they were using very lighter version of algorithm. So, but that's not in the market anymore. So we're safe. Okay. Thank you, guys.